Hey everyone, welcome to the next round of From the Experts. So this is the link bringing together folks that really know how to execute in the built environment. And specifically, today we want to talk about enclosure errors. So some of you may have seen an earlier one where I had Tony Ferrante, who's with us again today. And in that one, he really talked about some of the ideas and some of the almost theory behind how to avoid errors and issues with enclosure. Today, we're going to kind of pick up where we left off and dive a lot deeper into some of the details and some case studies. A lot of you probably haven't seen the first one, despite how amazing Tony did. So I'm going to go through just a little bit of intro. So Tony's today's expert. I met him actually when he was presenting some of this material at the CSI's national conference. He's senior building enclosure consultant at a company called BPL Enclosure. He's been at this 40 years, actually started in the concrete world. 25 years ago, he came into commercial roofing, so really understands what goes into the enclosure, and has been a manufacturer's rep and so on. He's with BPL Enclosure. They're a national team of building science experts. Lots and lots of experience in providing this sort of thing, whether it's third-party peer reviews with designers, QA work with contractors and owners, so looking over constructability and various other issues, but also can be the prime and architects of record when you're redoing something or renovating something, when, of course, a lot of times enclosure was one of the leading reasons for it, which is kind of why we're even talking. So, this is, I wouldn't call it one of the dirty little secrets of construction, but it's not as well known as it should be, is that water damage is something like 70% of the lawsuits in construction. And over 90% of those failures occur from just 1% of the enclosure. So the point being, the details matter. As important as design and upfront are, of course they are. The details really matter. And often, as we're going to see, sometimes that's catching something that an unrelated sub did when they were kind of finishing something, or maybe they punctured the vapor barrier, all these other things that we'll see in a minute. But the point is, it's often not something big and glaring that winds up over time really causing an issue. And again, we'll hear about that more. So again, today's session is a deep dive into some examples. I'm going to hand this over to Tony, who's going to drive. He'll ask me once in a while to pass from one slide to another, but generally, Tony, this is welcome to today. Really
Well,
excited to hear your examples and case studies. Some of them are eye-opening, to say the least. So with that, I'll hand it over to you.
thanks you. I really appreciate this opportunity. Yeah, the case studies help illustrate the fact that the problems that occur on a building with specifically leaks and the different issues oftentimes aren't easily discerned. You have to step outside the box and look at it from a broad standpoint and try to figure out and wrap your head around what possibly could be causing this. Water in a building isn't always a hole directly above where the water's coming from. And so it takes people, building science experts, an opportunity it takes them to look at it using their experience and figuring out from other failures that they've encountered in the past to try to figure out why this current problem is occurring.
And if I can
So we can go,
expand on something, if
yeah,
I can expand on something that you talked about in the first session, a lot of times the water isn't dripping from point A to point B, and point B is where the damage happens, right? A lot of the times it spends some time as moisture, right? That gets let in little by little, and then it condenses into water or stays as moisture and causes issues. So that's kind of one of the points you're getting at is a lot of this stuff isn't obvious because again, there's no glaring hole, there's no big drip, there's no noise being made. It's over the course of some amount of time, whether it's 6 months or less or more, that a small issue can accumulate and turn into a big issue.
yeah. I mean, my favorite on that was water intrusion coming through microwave ovens in units, and people, that's the weirdest thing. You wouldn't expect a roof leak or a window leak or a wall leak to be coming into somebody's microwave oven. And what was occurring was the exhaust piping from the exhaust of the microwave was set up, and there was outside air intrusion in there, and it was condensing in the vent piping of both the microwave oven and the dryer vents. But because the dryers were running, they were drying the condensation out, and the problems weren't manifesting themselves. But with the microwaves, the water after it condensed was just running back into the microwaves. And it
Crazy.
was, yeah, crazy is a good word.
Oh, cool.
So we can go to the next one. So when you've got your buildings and people are familiar with curtain walls and curtain wall systems are getting more and more prevalent. The glass towers. I live in Atlanta and it's amazing to have lived here for almost 50 years now and see the glass towers downtown. So when curtain walls are built, they provide beautiful aesthetics and they help with the design. And oftentimes the curtain wall that's on the side of the building comes up beyond and becomes its own parapet wall or as a guardrail for like outdoor plazas. And in this case study, the curtain wall came up and then there was a plaza on top where people could step out and, you know, view the sights and everything. So on the next slide, you'll see that the original construction was watertight when it was put in and we water tested it and it worked great. But then we started getting called. We got a call from the owner that water was coming into the spaces beneath this plaza. So we went out there and lo and behold, when we had tested it, it was when the water barrier had been installed. And after it was tested and proved to be watertight, a contractor came in and decided that the way they were going to dress this up was they threw this mismatched bronze piece of coping, for lack of a better term, on it. And they were so unprofessional. You can see where they hand snipped this thing to get it around the supports and then used clear silicone caulk that they probably bought off the shelf at Walmart to try to make that watertight. So one of the best maxims you can use in the construction industry is if it looks wrong, chances are it is wrong. And nobody should be able to look at that detail on the right and say, oh, that looks good. So when you go to the next slide, we came in to try to figure out and do like reverse engineering and the forensics of it. The person who was asked to dress this up actually threw a wood nailer on top of the ledge that was totally superfluous and wasn't needed. And in installing this unneeded wood nailer, they then punched holes through all the waterproofing. And then they put T-bar into the existing waterproofing, putting holes in that as well. And then they attached that gross piece of coping on it. So we had to have them come in and it was a different contractor. They removed the T-bar, they removed the wood nailer, they reinstalled a true waterproofing, water resistant, waterproof layer on that. And then the finished product should be on the next slide. We had we then covered it with more waterproofing. And then the final product was a coping cap that went over that base flashing. Go to the next one. And they matched it. I mean, first of all, they matched the same color of bronze. It's not hand snipped, it's not sealed, but the important thing is there were no intrusions, no penetrations through the waterproofing. And it's very frustrating for the building owner because, it had gotten this seal of approval that when the waterproofing was installed, that it was in fact waterproof. And then a separate trade came along and totally destroyed what was there.
And that's kind of the point we're trying to make today, I think, is that a lot of times the design, the original design and the original installation and the original build is often fine, right? But either at the end of the job or later on as things get adjusted or whatever, it's important for everyone involved, whether it's the GC or the owner, to really understand that is the subcontractor who you brought in aware of issues like this? Are they qualified when it comes to waterproofing and enclosure? And a lot of times, to your point, they're not.
No, they're not. And so it's very important to have kickoff meetings, a lot of communication between the trades, people that are working in the same area, the same part of the building. They should have a ready flow of communication between them so that they can, understand what each other does. I mean, we're not asking everybody to know what everybody else does, but at least have a general understanding of what my work might do that affects somebody else and then affects the building's performance.
But
So the
also, I
next
mean, I
case,
think,
yeah,
well, before we go on, I think inherent in that also is that there are a couple of really key points of risk, and one of them is this: fire and safety is another one, where it is worth it to get a consultant in there if you haven't already, just to make sure that somebody's looking at it purely through that lens. Because again, a lot of times things get missed, or people make assumptions that aren't accurate. I'm sure when this was presented, the original kind of refit, that there were assumptions made that they knew what they were doing from a waterproofing standpoint, and that they understood what a water barrier is. And clearly, that wasn't true. Whereas a good consultant probably would have asked a series of questions that might have gotten to that, and either disqualified that subcontractor, or at least made sure they didn't do any more harm.
case study number two is the problem that you get when you have exterior entrance doors. The majority of exterior entrance doors, if they are for egress, it is unable to make them 100% watertight. So back in the first class, we talked about the 4 Ds of waterproofing or rainwater management. And the number one is deflection. So that's why it's very important if you've got exterior entrance doors that you deflect the water. You have a canopy over it. You in some way, shape, or form keep the water from hitting up against that door or pooling in front of the door. But on this particular building, on the next slide, you can see that the way it was designed over to the right is where the door that we were looking at is under there. There's a canopy above it, but you can see that it's so much higher above the door that it's really not providing any deflection for that door. So they were getting wind-driven rain up against that door. Water was pooling at the base of the door, and there was no way to make it to give it a full weather seal. So that's when you have to drop back and punt and say, okay, we've got a situation where they didn't want to add a lower canopy over that door to keep the water from getting in it. They couldn't, they were stuck on what they had to do. So the next slide shows the only acceptable remedy for that was the slab. There was a slab depression with a drain and a walk-off grate so that the water that was, understood is going to continue to come into that without redefining the entire building and violating, codes and everything else with an interior egress door or an exterior egress door. That was done as a solution so that if any water came in, you no longer had slip and fall hazards. The water had a place to go. It could be managed and you weren't running into problems with mold or flooring issues. So that was how that was fixed. This is one of my favorites. This is a curling ice rink facility up in Minneapolis, up in Minnesota. It is the largest curling rink facility in North America. Curling is that Olympic sport where they've got the guys with the brooms and they're sweeping the ice as they throw that kettlebell looking thing across the ice. They had a problem. Now, this facility actually has the Olympic curling teams from, I believe, Canada, the US, and from abroad come and train at this facility. And they had water dripping from the roof deck and truss system. And the managers, I mean, these guys are, they're like rink managers. They're not enclosure consultants. They're not waterproofing consultants. The only way they could figure out to keep the water from dripping from the underside of the roof deck and onto their ice and onto their patrons was to bungee cord buckets from the rafters to catch the water. And they didn't even get matching buckets.
Yeah,
That's
yeah.
what really, well, the first time I saw this, I was like, oh my God, they didn't even get, they could have at least gotten all white buckets and they wouldn't have stood out so much or in the same color of bungee cords. There's actually was a person whose job description was like every third day he had to go around in a cherry picker and get the water out of the buckets. So they called us in to see if we could help them figure out why they've got the corrosion on the doors, the corrosion on the roof deck, why they were having all these condensation problems on the stuff that could rust. So we went in on the next slide, and there had been previous they put in dehumidifying units in the arena, which will lessen the humidity, and they spray foamed the wall to the roof connection around the arena, which was a decent step, but it was like a band-aid on an open wound. It wasn't really stopping their initial problem. And we got deep. You can see that. I mean, that's a big facility. So we started with smoke tests to figure out what was happening with the air because we knew enough about the building science that the condensation was because warmer, moist air from outside was being drawn into the building. And once that the moist air reached a surface that was below its dew point, it then condensed on that surface.
What's a smoke test?
So go to the next slide. The smoke test is as simple as a guy has a little smoke thing and he goes and he walks around the building and someone's inside the building and someone's outside the building to see where's the smoke coming in. And from this map, you could see that all these little blue areas are showing the ice rink is the main body. Beneath the ice rink was locker rooms, and the smoke was flowing in from the outside. They had spray foamed the deck to the wall, but they still had massive air leaks. They had virtually no air barrier going on. And when they spray foamed the deck to the wall in their first attempts, what they did was instead of a big straw, they made a bunch of little straws, which, if you've got a tire and it's got 99 holes in it and you fix 98 of them, you still got a flat tire. If you've got an air leak issue, you can fix half of them. It's just going to make the other ones flow at a greater rate. So we were able to find out through the smoke test that it was coming in from the outside into the ice rink. It was also coming in from the outside into the locker rooms. And then it was proceeding into an amenities area and into the kitchen snack bar area. And that started pointing us into clues as to what some of their issues were, aside from the fact of a lack of an air barrier. Go to the next one. We found the culprit. Kitchens have exhaust fans, and it takes a talented mechanical engineer to figure out just what the flow rate needs to be for the exhaust fans in the kitchen. They have to have exhaust fans for each flat top grill, each shortening fryer vat. And oftentimes in the restaurant industry, they will over engineer their exhausts based on, well, if we get busier, we'll put another flat top in here. So we may need X amount of exhaust being pulled out. Let's go ahead and build it for 1.5 times that in case we have to add more grills or more fry vats. So they had these exhaust fans in the kitchen that were in essence sucking all the air from the building through the kitchen exhausts. And when you're pulling air, it has to come from somewhere. So we started getting with the owner. You go to the next one.
Well, real quick, it's an interesting one
Yeah,
just to paint the picture. When you talk about laboratories, they often want to have positive pressure to make sure that anything or negative pressure, excuse me, so that no air escapes. What you're saying here is because these were presumably running all the time, or certainly during business hours, whether they were needed or not, they were creating lower air pressure for the entire building, enough that at any given moment it was pulling air in what that might not have made it in otherwise, or certainly not at the rate that it was coming in. Is that what we're saying here? Is that it's crazy, but it's the entire building had slightly lower air pressure because these things were humming away the whole time.
absolutely, absolutely. And there's supposed to be an inlet. When it's created effectively, they've got an inflow of air that matches the outflow of air, so they've got their own closed circuit. But sometimes those fans make some noise, or they might have a bad bearing, and so somebody's not in the know, and they flip a switch and they flip it off.
Yeah.
And so if you cut off your inflow of air, those massive things drawing the air out have to get air from somewhere. And sometimes you can think back on in your life when you've ever gone to a business and it was very, very difficult to open the front door of a
Yeah.
business.
Yeah. That's
That's the
interesting.
situation. So we did infrared imagery and we showed specifically where your heat and your air intrusions were happening. Um, This was showing that not only was it the edges of the deck, but it was in places where the deck uh, seamed itself, where the two different pieces of decking were on. There was not a good air barrier or air seal with where the decking was, and that was pulling heat. And then on the next one, the building was designed with a dock door in the back, and it was air and heat was just flowing around that dock door. And so that was another massive straw that was letting this very warm, moist air come into the building. They also had a foyer that uh, they also had a door, an open door. And in speaking with them and trying to get them to understand, instead of a door going straight from the interior space to the exterior space, uh, we posited the possibility of adding a foyer there,
Hmm.
uh, so that there would be a delay in the air, and it could be, a much more airtight system by having an exterior door and then an interior door. So then we got the owner in touch with mechanical engineers. So the mechanical systems needed to be balanced. The kitchen exhaust hood shouldn't sabotage it. It should run slightly positive in a northern climate. And ideally, the ice arena should be positive to all the surrounding areas so that it wasn't drawing warmer, moist air into the ice rink. The colder, drier air from the ice rink could get pushed into the surrounding areas better.
Hmm.
So um, they worked even better at finding the details of where the air was coming in, and then repair and replace the HVAC and the exhaust fans and get that all operating and running well. So the good news is they were eventually able to retire the buckets and the bungee cords.
And when you do this sort of thing, I'm assuming you very often find people are surprised by where the air is coming in from, right? I mean, a door and the big kind of truck door probably wasn't a huge surprise. Some of the other areas, it sounds like were.
Absolutely, absolutely. And it's and it runs back to the fact that in the actual initial construction of it, had they been paying attention to the air barrier, this could have all been handled in the design phase. But when this building was being designed, or when many buildings are being designed, they're not even thinking about the need for an air barrier. And so that's why, um, getting with professionals, enclosure professionals who are cued into this and have an eye for it is really important, because it definitely affects the performance of it. And it's one of those things where, it's a whole lot easier to head off the problems before they can become problems than it is to try to fix them after the fact.
If for no other reason, you save on buying buckets.
And the cost of the guy going around and dumping them out.
That's right.
So this one is a multifamily situation where you've got shingle buckling up on the roof, and you look at it, and everyone's first thought when they look at this, or most people's first thought is, well, the roofer did a bad job. It's bad product. That's the roofer's fault. Well, it's not really the roofer's fault, because this building happened to be a wood structure that has CMU stairwells. So the wood shrinks and expands based on its moisture content. There's an equilibrium for wood. And if you're not planning for it, really bad things can happen. So in the next slide, we started digging into what was happening, and you had the wood framing butted up into the concrete stairwells.
Hmm.
And there was a break between the wood beyond the concrete stairwells and the tornado sheltered concrete stairwell. When the wood beyond the stairwell started its shrinking, the roof deck actually shrunk, and they had already roofed it with the shingles. So the shingles are buckling because the deck was in, couldn't shrink in the area of the concrete stairwell in the same fashion as it did beyond that. So that's why there's that ridge of the shrinkage. So that's another thing it's an insidious little thing that's in the back of the mind, but until you actually see it in practice, it's just a theoretical thing. Yeah, wood shrinks or wood expands when it gets wet and it shrinks when it dries. But when you start seeing what the effects are of mixing your structure types and not accommodating for that, it can it can really impact the performance of the building over time. So the next one talks a little bit of how trusses can deform because the way it is with the top being exposed to the elements in the sun and the heat and the cold, and then the inside that's protected, the bottom cord shrinks and the top cords lengthen, and you end up with a bow of your truss. It's something that's important to be aware of, especially when you're designing the building and you're mixing the building materials, because it's going to happen. Wood is always wood is a much more susceptible to the elements than some other building materials. The next slide shows some ideas of what can happen. Siding can buckle. So if you've done your enclosure and you're using hardboard siding, the expansion and contraction of that can cause that to buckle from the shrinkage. The next one shows that you have shrinkage between floors. So when you've got a wood frame building, your different floor levels are going to shrink. And if your cladding to the structure doesn't accommodate and anticipate the shrinkage, you can end up with metal wall panels, eaves, masonry, all these different things having problems because the interior structure is moving and the cladding didn't accommodate for that. So you can, and windows and doors, you can get into some serious things when you don't anticipate the shrinkage and what it can do to the enclosure.
And what do you typically do about that, other than not use wood?
Well,
It looks like here you're saying you're giving yourself the equivalent of like on a bridge or in a railroad tracks where there's a gap that allows for expansion and contraction. It sounds like you're doing the same thing, but also earlier where you had wood inside of concrete, essentially, it's hard to do that, right? Because if it's a structural member, you can't really have a gap. So is the argument you shouldn't have it inside of the CMU, it should ride on top of it kind of thing? Like what are the solutions?
the deck can free float. It can. There's also many different expansion joint uh, assemblies for claddings, for the walls, between the floors, and then on the for the roofing. So an expansion joint, but then you have to accommodate that with the shingles that then cover the deck
Right.
for the expansion. So it's a design thing, going back to the drawing board on that, a free floating deck, uh, an exterior deck above the structural deck that would then be roofed so that everything that moves underneath it doesn't impact what's happening up top is sometimes a a remedy for that. But that takes engineers, um, structural engineers to help with in the architectural thing.
Yeah, the takeaway being when there's wood involved and it's likely to, be in a position to absorb moisture, need to go figure it out. Like it's just
It,
kind
it,
of depends on a lot of things. Yeah, makes sense. Okay.
so this is a cistern detention vault that was part of a parking deck, and there was, you know, leakage. Of course, you can tell from the pictures that water was leaking, and it was, the first thought was, how is this happening? I mean, these are poured concrete, thick walls. Why are we getting water out here? And the challenge was, finding out what was going on. So we dug deeper into it, and all concrete is has micro fissures. Concrete is going to crack, and the capillary action of water going into those fissures is the main reason why you need to have under slab vapor barriers. uh, below grade waterproofing. Because oftentimes the blind mental thought is, well, my concrete swimming pool doesn't leak. Well, it doesn't because it's waterproofed. So we had to go into into the cistern. Go ahead and go to the next one, and actually put waterproofing on the interior of the cistern to seal that off because
Hmm.
it it hadn't been done correctly. So we, in essence, turned the cistern back into a watertight container so that it wouldn't leak through the walls out into the parking deck.
So, and I mean, the point of a cistern is it's containing water or fluid.
Correct.
So, had they just originally installed it wrong, or over time,
They had a,
they're okay?
the original installation was not adequate for what it was
Yeah,
supposed to have been.
interesting. And what's the takeaway for someone that doesn't do that for a living? Is to keep an eye on how it's being tested, or just make sure someone who knows better looks at the methods they're using and I don't know, inspected is maybe not the right word, but are they using the right materials? Are they
It,
using the right application?
it's always better to have a second pair of eyes. That's where CA functions is such an important thing, along with the third party peer review during the design process,
Yeah,
because you can figure out if the materials are compatible with each other, if the materials are going to actually perform in the manner that you're hoping they perform. And then CA, the second set of eyes, making sure that the contractor who's supposed to be doing it is actually doing it in the fashion they're supposed to.
got it.
This is one of my favorites. This is a rooftop terrace that was over a hotel in Augusta, Georgia. And it was great. They were loving it. It was really cool. Well, if you've ever been to Augusta, Georgia, the sun can beat down on you and it can be somewhat warm. So they said someone came in and gave them a bid to put a pergola over the top of the terrace so that people could sit in the shade. Well, what they did was they drilled they drilled down into the existing rooftop terrace so that they could structurally bolt those columns into the decking. And in doing so, they opened up the waterproofing at each one of those locations. So the terrace was totally waterproof. And then they decided they wanted to put up this pergola. And the guy who came in just destroyed the waterproofing. You know, when you put holes through the waterproofing, it's not waterproof anymore. So every one of the hotel guests on the top floor was getting intense amounts of water into there. So we opened up the ceiling. You could see rust on the bolts that they used to bolt down those columns where the water was dripping in. Then it was destroying the drywall ceiling of that hotel room. The water was living in the drywall. It had that nasty hotel musty odor of mold. I mean, it was bad. Some of the rooms were unoccupiable. And when you're talking about a hotel, that's their profits. So we went in, go to the next slide, and cored down around that and saw the waterproofing lap. So without removing the columns, we were able to core down into the deck to the waterproofing mat. You can see the little dimples on the waterproofing mat down through that picture of that core. And go to the next one. A low viscosity acrylic resin that was literally the same viscosity as water was poured into the cores next to each one of those so that it ran along the drainage mat. And then when it cured, it reinstituted the waterproof capabilities of the waterproofing membrane. And from the underneath, there were drain tubes for the excess to come out. The the rusted out bolts and nuts had gotten replaced. The waterproofing was put in. Once that all sealed up, all of the holes that were put through the drainage mat were repaired, and they no longer had any leaking problems.
There's something cool in what you just said. You guys used a sealant that was about the same as water to just follow where the water went.
Exactly.
That's interesting. Is like let's just have it do what water does and then solidify and you've covered most or all of it. Really interesting.
That's Yeah, it's a product that um the the chemical engineers who came up with that, I hope they are financially compensated quite well for that because it's a very useful invention that they came up with. Because, like you said, it follows the path of the water. And then when it's in there, it hardens and prevents any more water from following behind it.
Yeah, very cool. Especially because water gets everywhere. So if you've got
What
something that can follow all those little places it might go, really a neat way of solving the problem.
Water is the best detective. It is going to find the
The best
path of least
detective.
resistance. Yeah,
Yeah.
water is going to find a way. And you
Water is the
go to the
best
next.
detective. Go ahead.
Yeah. So this was a cool case study. These windows were thought to be leaking. And so once the windows were installed, hey, we got water around our windows. They called the first, window guy. He came out and threw down sealant. Then, that didn't fix it. So they called somebody else. He came and he put more sealant on. Used to call it the sedimentary rock of sealants. You can go out to job sites that have chronic leaks and you can just see the layers of different sealants and the different colors and the different aging of the sealants. Anytime, and like I said, if it looks wrong, chances are it is. If you've got a building and you've got sedimentary layers of sealants, they're not fixing the problem. The problem is something other than where they're putting those sealants. If the place that is receiving sealant is the place that's the problem, the first layer of sealant should have fixed it.
Hmm.
So that's always a clue that you might want to look deeper into it. So with these windows, you can see from the inside, we were doing spray tests on the windows from the outside. We opened up into the wall cavity above the windows. And the when this first came to me and I looked at this and I said, look above the window to the left. Look at that exterior light that got stuck into there. I said, I'll bet you that light's not sealed. So when we went into the wall and we started our spray testing, go to the next one, we proved that the water that had been manifesting itself as a quote unquote window leak was actually coming in through that exterior light that had gotten punched through the sides of those concrete panels. And the water was coming in there, running down the wall, hitting the top of the window, spreading around the window, and making itself look like it was a window leak when in fact it was the people who put that light in.
But I'm seeing at least one pattern here, and that is after something has been put in and put in properly, somebody later, whether it's during the original build or very often later, is punching through these holes, right? Is that, as you think about where you guys get pulled in and where you're solving problems, it sounds like that's by far the most prevalent thing is that designs are usually okay, and the original build is often okay, but it's when somebody comes in later and punches a hole in it that you often are finding problems. Do you find that that's the main way that you've got issues, or am I overgeneralizing?
I'd probably say it's 60-40. 60% of the time is after the building has been commissioned, they've received their certificate of occupancy, and then somewhere down the road, somebody decides they want to add more exterior lighting or they want to add a pergola. That's probably 60% of it. 40% is like the ice rink that was just poorly designed and they just ignored the air barrier
Hmm.
from the get-go. Um, so it's always something where if you've got a persistent problem, go to the professionals who have dealt with finding the forensics of the persistent problems. Because what is insanity doing the same thing and expecting different results?
Yeah,
If the first four times a window contractor caulked your windows, it didn't fix the leak, then obviously that's not the problem. You run
yeah.
into that quite often.
So sedimentary layers. That's a funny
Yeah.
image.
So when you're building a building, when you're operating a building, designing it, you need a collaborative team. If you look at this box, you got good construction, good design, and bad design. Think about it. You've only got a 25% chance of getting it right.
Hmm.
75% chance of failure coming out of the box. So, you know, Those red boxes are litigation possibilities.
Yeah, yeah.
The green box, the green box is where it's not going to be. So that's where it takes a team approach because the second set of eyes, the experienced professionals who understand the the minutia of enclosures helps a lot to keep you in the green zone and out of the red zones.
Love it. Awesome. Well, Tony, thank you. I really love this kind of thing. I love digging in and kind of giving people some examples that they might not have heard of. Everyone, that what's funny also, some of the examples that you gave, everyone has seen a roof that buckled. Everyone has been in well, not everyone, but lots of people have been in ice rinks that have dripping problems because everyone thinks of them as a barn. Probably why they didn't think about the air barrier so much is you just like this place is so big, air's going to get in no matter what I do. So really, really interesting to have you dive in like this. Thank you for your time.
Thank you very much. I really appreciate it. And if anybody has any questions, my contact information's on this. I love to chat.
And we'll have this in the notes when I put this up on YouTube. Tony, thanks again.
Thank you very much. Have a great rest of your day.